This meeting is being recorded.
Hello, my name is Saswat Chapagai, and today I am here to present on the final project of life contingencies, which is life insurance policy value calculator. So I would like to first begin by sharing my screen. So I would like to begin by introducing some key features of the life insurance policy values calculator. So it is built in R programming language with the sine wave interface. So only minimal output input is required. That is, only a mortality table is required as an input to calculate the assurance, annuities, functions, and all the premiums and reserves. And dynamic data validated user interface is enabled to prevent any kind of errors, to minimize the errors. So we have three integrated calculators. The first one, assurance and annuity calculator, the premium calculator, and finally the policy value, the reserve calculator, which utilizes the output from the 1 and 2. And as a whole, it is a wholesome self-sustaining actuarial engine. Now moving on toward the assurance and annuity factor calculation. So to dynamically calculate the assurance and annuity factors which are required for the policy and the premium calculation, so we have taken the value of Lx and Qx for ages 20 to 100 from the SOA SULT 5% table, and for ages 101 to 120 we have extrapolated these values using the Meckham's law, utilizing this constant from the previous project given, and we have utilized the formula Px for Qpx and Qx for extrapolation based on the Meckham's law, which is shown in the given figure. So the given Excel file which contains the age Lx, Qx, Dx, and Px from the age from 20 to 120. It is given as input to the R engine, and it calculates the required dynamic actuarial assurance and annuity factors. So we have used the commutation functions dx, cx, nx, mx, and utilize these functions to calculate the assurance and annuity factors, because the whole life assurance and your term assurance, pure endowment, and your endowment assurance, whole life annuity due, and your temporary annuity due, all these assurance and annuity functions, they are required to calculation in the premium as well as the policy reserve. So we have strictly calculated these in the R programming language utilizing these formulas based on the commutation functions. Now moving on toward the input handling and dynamic interface behavior. So to minimize the error, we have mandatory drop-down units. So interest rate ranges from 1% to 10%, age from 20 to 80 years, product type or lifetime and endowment, policy term 5 years, 10 years, and 20, which is only valid for the term and endowment, and the premium payment term as dynamic logic. So for the whole life insurance, the premium payment sorry, the policy term is not required, it is automatically hidden. The premium payment option is 5 years, 10 years, 20 years, and forever. And for term and endowment insurance, the user must choose a policy term that is 5 years, 10 years, and 20 years, and based on the policy term, the premium payment term also changes dynamically. If the policy term is 5 years, the premium payment term is shared dynamically automatically to 5 years only. If it is 10, it is 5 or 10 years, and if it 20, it is 5, 10, or 20 years. So this ensures that premium payment period, it never exceeds the product term which is required by the project. And for the product dependent logic, for the time at which the policy value is calculated, so if the valuation time t for the whole life product, it falls within the range of 0 to 100 minus x, where x is the input age given by the user and 100 is the 100 is our limiting age. And for the term insurance, if the policy term is n, then the valuation time t, it ranges from 0 to n and can be either 5 years, 10 years, and 20 years, and same in the case of the endowment insurance. Moving on toward the premium calculation formula. So the premium calculation formula equals to sum assured, which is given by the user as input, times the assurance value and the corresponding annuity value. It depends upon the premium payment term and the product type. Similarly, in case of the term life insurance, based on the different terms and premium payment term, we have a dynamic formulas across, and these formulas have the same structure, basic structure, but only things is the assurance value and the annuity value changes with the premium, with the policy term and the premium payment term dynamically. And for the endowment life, we have the similar formulas, and only the assurance values across the different formulas and the annuity value across the different formula, it changes based on the policy term and the premium payment term. Now moving on toward the policy value calculation, the policy value at time t is calculated at the actual present value of the benefits minus the actual present value of the premium. So in this given equation, we have considered the actual benefit, the benefit in a given insurance policy to be 1. Now for a more realistic example, for the formula which we actually utilize in the R engine for calculation of the premium, for the calculation of the policy values are as under. So for the whole life insurance, if the premium payment term is forever, we have utilized the same standard formula. Here this quantity gives the actual present value of the uh, benefit and minus the actual present value of the premium. And if the premium payment term is finite for the whole life insurance, and if the valuation time t is ranges from 0 and it is greater than 0 and is less than the premium payment term, we use the same standard formula. But if the premium payment term has already been passed and we are doing the valuation at time t which is greater than the premium payment term, then all the premiums are seized already, so we only have the policy value as the uh, actual present value of the benefit. Same in the case of term life insurance. So if the valuation time is within the 0 and premium payment term m, we have the same standard formula. If the policy valuation time t, it had exceeded the premium payment term but is less than the policy term, and then we only have the actual present value of the benefits. And if it exceeds the policy term, we have no policy value, that is 0. And it same goes for the formula across different policy value, chosen policy value, policy valuation time t, it's the same formula applies over here. So moving on toward the working mechanism. So we have the input of age, interest rate, product, policy term, premium payment term, sum assured, and policy valuation time. So these input are taken from the user, and the RStudio engine, it takes these input and calculates the annuity and assurance factors utilizing the annuity and assurance functions. And the premium function, they utilize the dynamic values of required annuity and assurance based on the input from the annuity and assurance functions, and it calculates the premium. And finally the policy value function, it takes the output from the step 1 and 2 and it calculates the policy value and shows out the output into to the user in the user interface. Now we will have a practical look of our application. So our application, it has three interfaces: assurance and annuity calculator, premium calculator, and finally the reserve calculator. So we'll go briefly through the assurance and annuity calculator. We have interest rates range from 1 to 10%. We have age ranging all the way from 20 years all the way down to 80 years, and we have options of calculating all the assurance and annuity: whole life assurance, whole life annuity, term assurance, pair endowment assurance, endowment assurance, and temporary annuity due. So we can choose any values over here with for all range, age, and interest rate, and we can instantly compute the assurance and annuity results. So this dynamically gives the assurance and annuity factors which are required for the premium and the reserve calculation. We can see one more example for term assurance for a different age 63 for 5 years. We can also choose the term and we can get the instant value over here. Now moving on to the premium calculator. The premium calculator has interest rate ranging from 1% to 10%. The ages, it ranges from 20 years all the way down to 80 years. We have product type: whole life, term, and endowment. For whole life, the premium payment terms are 4, 5, 10, 20, and forever. For term life, we have the premium payment term of 3, the policy term of 3 categories: 5 years, 10 years, and 20 years. If the policy payment term is 20 years, the premium payment term is 5 years, 10 years, or 20 years. If it is set to 10 years, we have only two premium payment term, that is 5 years and 10 years. And if it is set to 5 years, we only have single premium payment term, that is 5 years. The same goes in the case of the endowment insurance. Now to begin with a quick example, for the whole life, we took the interest rate to 6%, age to 63 years, and sum assured to be 100,000, and premium payment term to be forever. So we get annual premium and the monthly premium calculated. But if the user tries to input the negative number, so it comes an error and it says sum assured must be positive, value greater than 0. So it prevents manual error entry. So we can choose a different sum assured to be 80,000, or different interest rate of 2%, age of 45 years, a product of term, and we can choose a policy term to be 10 years, premium payment term to be 5 years. And if we click on calculate premium, we get the annual premium and the monthly premium accordingly. Same in the same manner we can calculate for the endowment insurance. Now moving on toward the reserve calculator. So we have the same interface as the premium calculator. The interest rate ranges from 1% to 10%. The age, it ranges from 20 years all the way down to the 80 years. And we have three product for whole life. The valuation time, it ranges from 0 to 100 minus the given age. 100 is the limiting age. Here the age is 30 years, so the valuation time must range from 0 to 70 years. So it ranges from 0 all the way down to 70. And for the term and endowment, for term, if the policy payment term is 20 years, the valuation time also ranges from 0 to all the way down to 20 years. And if it changes from 20 to 10, again the valuation time is updated and it all ranges from 0 to 10. It never exceeds the policy term. It may exceed the premium payment term, but it never exceeds. Same in the case of endowment. Now to begin with some example, we choose at first the whole life insurance. We can change the interest rate to any desired value. The age from we can choose 32. Whole life we can change the premium payment term to 20. The valuation time we can set the valuation time at 7, and using the sum assured of 100,000 we get the total reserve, that the policy value at time 7 to be 7407 dollars approximately, and reserve per $1 at time t, that is the 7, is also given over here. Now moving on to the different interest rate of 1% to a different age, say 37, and we can choose a term. We can choose a policy payment term to 20 years. We can also set the premium payment term to 20 years, and we can choose the valuation time to be 19 years, and we can change the sum assured as well. If we change the sum assured to 200,000 and we click on calculate reserve, so the total reserve required at the time for this portfolio is $239, and reserve for $1 at time t is the given amount. Now we can choose a different option for the endowment. We can choose the interest rate for 8 years, it's interested to be 8%, and we can choose a different value of age for 46 years. We can choose the policy term to be 10 years. Policy payment term can be changed to 5 years, and valuation time it depends upon the policy term, so it's range from 0 to 10. So we can also exceed the premium payment term. Let us set to 6. So in this case we only get the policy value that is reserved as the actual present value of the benefit. So it's 147,122, $147,122. So in this way we can calculate the reserve dynamically based on different inputs, and we also have a reset button which resets all the values to the default values, and we can calculate different values accordingly to with different inputs. Thank you so much.